with today's class. Actually, whilst I'm talking about Rhino, it has a really strong community, which is one of its strengths. So if you have any question and you go online, you will very likely find an answer. If you don't, you can ask and someone will answer you very fast usually. So discourse.mcneil.com is the Rhino forum where people get help and post things. Grasshopper3d.com is the forum for Grasshopper. So you have tutorials, support, and conversations where people chat about the newest things, ask questions, get answered. I mean, the guy who designed Grasshopper will answer your questions sometimes. That's the strong community of Rhino Grasshopper. And then Food for Rhino is the last website I wanted to show you. That's where you can download a lot of plugins for mainly for both Grasshopper and Rhino. A lot of people just code. A lot of it is open source because of that community. Not all of it. Some plugins you have to pay for, but you have a lot available. You can make up your own plugins if you want later down the road. Yeah, so these are 3 useful websites to be on. So Rhino, that's what it looks like. So typical CAD software, I guess. You have, when you open it and don't do anything to it, you have 4 viewports: perspective, top, front, right. You can move on them. If you press down the control key, you can zoom in and out. If you press the shift key, you can just move on the plane. You have 3 ways to go about things on Rhino. You can use the icons on the side here. You can use the menus up there, or you can use the command line up here, which I guess when you're more comfortable is the main thing you'll be using because it's so easy. You just type stuff. If I want to draw a line, I just type line and you can draw your line. If you want to draw points, same, and you can do everything from the command line. So yeah, but I guess when you're beginning, maybe these menus are easier to follow. So the little icons represent what everything does, and then if you have a black arrow in the bottom right corner, it means you have a cascade menu, so you have more options. So for example, this one will be multiple points. So if I select it again, I can draw multiple points. Always pay attention at the command line. So anytime I select something, it tells me what to do. So start polyline, next point of polyline. And up here, the thing in brackets are options. So you can do things differently if you want to. In this case, I can undo. Yeah, always pay attention to the command line. Yeah, I guess we can move on to the first exercise. If you do file open, if you've played with anything, you don't need to save changes, I guess. And if, hopefully if you've downloaded the file I was mentioning earlier, so in my case it's not here, it's there. If you go to models and open start, you should get something like this. It's already there. Yeah. So earlier we had 4 views. Now whoever created that file has changed it to 3 views. If we want to go back to 4 views, all we have to do is click on that icon up there, and that will bring you back to 4 views. Again, here you have a drop-down menu, so you can set up different views. And if you hover over the icon, you can see that you get different things by doing a left click and a right click. So left click will set up my views that way around the origin, whereas right click in my case will zoom out as much as possible on all of my objects. Yeah. If you double click on perspective, you can maximize the perspective view. And if you, next to perspective, you have the little arrow. If you go down it, you can see you have different display options. So we can go to shaded and then it looks different. Another way to do that, so Rhino has a lot of ways to do the same thing. You have shortcuts, and as you go along using it, you'll find ways that you prefer. I think two people who are really good at Rhino to do the same thing might have different ways of doing it, just based on what you prefer doing and what you find more convenient. So if we do Control Alt and R, for example, then it moves to rendering. So Control Alt and S will go back to shaded. So yeah, that's some shortcuts you can be using. If you want to switch views, you can use the little tabs at the bottom down here. But you'll see people probably using Control and Tab just to switch between the views easily. If you get, so let's go to top view. If you get lost in space and you don't know where you are anymore, you can go back to this 4-panel view and it will bring everything back in display around your origin, as I said earlier. Alternatively, if you type ZEA for zoom, extend all views, again, it's the equivalent as doing the right click I was showing earlier. So if we go back to perspective, you can play around with the different displays. Rendered I was showing earlier already. Ghosted is a bit like shaded, but you see through it. You can get technical, so it's like a technical drawing. You can see the hidden lines are dashed. Artistic, I don't know. I'm not sure you'll use that this one that much, but you can use pen. Anyways, yeah, loads of options. If we go back to rendered, you'll see that the objects have different colors. So if you select one of them, on the right panels here, in properties, you have this thing called material, the little green thing. And so each object has been given a different material with different properties, which is why they look different. But if I go back to shaded, then they all look the same, and that's because of the layers. So the plane here is in one layer, and the objects are in another one. When you work and you have a lot of things going on, sometimes it might be easy to just hide some objects. So if you want to hide all objects in a layer, you can use that little bulb here, and it will hide all objects in the layer. If you want to hide just one object, if you select it, and then you have this bulb up there, if you select it, then it will hide just that object, and then if you right click, it says show objects, so it will make all of the objects appear again. When you work on complicated projects, I would strongly recommend using layers. They will make your life easier. You can activate, deactivate them. For example, you would draw your construction line in one layer, then you draw on top of them, and then you can hide your construction lines so it looks very neat and you don't get too messy, hopefully. Then if you select an object, you can move it along. So in my case, I have the gumball option toggled on down here, which makes appear these 3 arrows. Oh yeah, Rhino uses the right-hand rule, so X, Y, Z for the right-hand rule. I guess you're all familiar with it. But yeah, if you get lost in space, you can go back to the right-hand rule. So if you have gumball toggled on, you can move your object. If you click on the right arrow, then you will be able to move only in the x-axis, and then similarly for the other two. If you don't use any of the arrows and just move your object, then you can move in any direction, but that can be quite messy when you have a lot going on. So you can just play with it. You can try if you want to pile. If we go back to 4 views, if we remove gumball, you can try by, this one is gone up now. You can try and make the current go on top of the cube, for example, but by using the different views. I don't know, just practicing. Oh, by the way, in the thing you downloaded earlier, the level 1 training guide, here this is a 3-day course. The training guide is for a 3-day course. Here we have 2 hours. So I'll show you some basic stuff, but you feel free to, like, it's free, you have it now. You can save it to a USB or whatever, or download it again. There are a lot more exercises, only on Rhino. So you might find it useful. It has more tips than what I'll give you today. So I think it's a good base to be working with. Yeah, let's move on to the next exercise. So if you go File, New, and select Small Objects Millimeters, you should get something like that. And actually, what we'll be doing is drawing this plate. So yeah, we'll go about doing this plate. I have the picture of the plate, so I could use, you can't do that, but I could use picture frame, load the plate into Rhino, and I could, so it has all of the lengths and everything. So if I do scale 2D, I can scale my drawing. So all the time read the command line, it tells you what to do. So press enter when done. Origin point, first reference point, and then if I enter my length, so in this case 36.77, it will scale it, and then I could just draw on top of it, and I'll get the plate. You guys can't do that, and also it's not necessarily very accurate, but if you have like technical drawings of a 3D object, you could put the pictures in the different planes and use it to draw on top of it if there's an object you want to reproduce or something. So yeah, picture frame can be useful. And then yeah, all I'd have to do is do polyline and draw on top. It might not be very accurate to do that, and I'll show you another way to do it anyway. So if you select polyline or type in the command line polyline, we'll start doing it. So we'll start from the middle here, we'll go around, we'll stop there, and then we'll just mirror about the axis of symmetry. So our first point, let's put it at the origin. So in Rhino, as I said, you have many ways of doing it. So we could, if you toggle on down there the grid snap, it will mean you stick to the grid. So actually if we maximize top view, then we don't have to worry about the other ones. So you could toggle on grid snap and snap here, or since we're in 2D, we could enter the coordinates, which would be 0, 0, and that's your first point. The next point, again, we have many ways of doing it. So we'll do absolute coordinates for this first one. So it's at 20 in X and 0 in Y. So if I type 20, 0, I get my next point. Then the next one, okay, you can hand calc the coordinates, have fun. Otherwise, you can use length and angles. So if I enter just 8, so I know my length is 8, and press enter, it gives a length of 8. No matter where I click, the point will be at a distance of 8. And then if you use the less than sign and the angle you want, it will give you the angle. In this case, it's taking the horizontal here, so 120 will be there, which is not what I want, so I'll just do 60. And so now you can see your line is only going at 60 degrees. So if I press somewhere down here, no matter how far from the point, it will put my point at length 8 and the angle I want. Okay, next point, 16. So this time we can again use the length, 16. If I could toggle on ortho down here, which means I can only go in the orthogonal directions. So we could do that. Another, if you don't want to do that, you can just hold the shift key, and that basically toggles on ortho temporarily. So if I type 16 for the length and hold down the shift key, then I get my new point. For the next one, I guess we could do one of the techniques I've already showed you. Another one is relative coordinates. So if I type R and then my coordinates related to that point, so in this case 0 and 40, I get the new point I'm interested in. So I guess you can use a mix of these techniques to finish the second half. So I guess now the next few lines are all orthogonal. So if I toggle on ortho, and then all I have to do is type in my length, so 8, click, 8, 8 again. Then the next one is 40. And the last one is 8. So now we're back to going at an angle. So we'll do again the length and angle. So the length will be 36.77. And the angle, so we don't want ortho anymore. We want the angle, so less than 45. And so now again, you can only move at 45 degrees from the horizontal. So we'll want to be somewhere there. Since I know I want to finish there, so I know the length is 6. Since I have grid snap on, I could just go straight and snap. Actually, it's not really snap. So if I hold the shift key, then I'm sure I'm orthogonal. And I can stop there. Otherwise, you can enter 6, hold the shift key, or toggle on orthogonal, and you'll be there. Okay, so now we're done. Press enter when done. So we press enter. And we have this. If you go up here to properties, and you've selected this thing and you go to object, you can see we have an open curve. So that's one of the types we work with in Rhino. Now we want to mirror it. So in your command line, if you just type mirror and do as you're told, so select object to mirror, enter. Start of the mirror plane. We want anything on the z-axis, on the y-axis, sorry. So you could pick any point that's on the axis. If you toggle on O snap, you see you have a few options that appear down here. So this snaps your cursor to one of these things. So if I select endpoint, then I could go here and it will find the endpoint for me. So when you draw with many lines, many objects, that can be quite easy. You have to be careful which options you select, because it can be quite messy if you have a lot of things overlapping. But if I select the endpoint and then I go to my end of mirror plane, so the other endpoint, then we have our plate. But at the moment, we have two open curves. If we had drawn everything at once and closed back here, we would get a closed curve. So down here, again, you could just type join in the command line, or here you have the icon to join. So if select object for join, you select your two objects, and now we have a closed curve, as you can see in the properties. If we go to perspective and we use shade, actually, we can create a surface based on this line. So when you start and you don't necessarily know what you can do, I would suggest if you go to so this one is the surface menu. If you drop down, you can see the different ways to create a surface. And the second one happens to be surface from planar curves. So if you select that, then you get your surface, and you select the curve you've created, then you get a surface. If you're going to shade it, you can see it. So yeah, you've created a curve. There are many ways to do things. People will do it different ways, but yeah. And now if we wanted to create a solid, we can extrude this. So this one is the solid menu. So there's two ways to extrude. You can extrude from planar curve or extrude surface. So we'll start with planar curve and we'll extrude, we'll take curve. And we can extrude, so if we type, for example, yeah, whatever. If you extrude one side or the other, then you'll get something like this. The other one I was talking about was extrude surface. So if you do that, and you pick your surface, enter, and you extrude this one the other way, for example, you'll see we've done twice the same thing almost, and yet we get two different looking things. So this one has extra lines, the bottom one, whereas the top one has nothing. So if you click on it and see the type, this one is a closed extrusion, whereas the bottom one is a closed polysurface. They're basically the same. Closed extrusions are just very simple. As soon as you do anything to it, it will become a closed polysurface. So if I do Control-Shift, that's to subselect, and then I select the top face. And then if I put the gumball on and I just move this one up, so to extend my volume, then you see the lines appear and it's become a closed polysurface. Rhino really has three main categories. So you have lines, I guess you have points to start with, then you have curves is the official name. Lines fall into the curve category. You have surfaces, and volumes are just closed polysurfaces. So if I explode this using this little icon or typing explode, I end up with open surfaces. So yeah, and then the last type are meshes, and we'll talk about that a bit later. Yeah, so we've created a solid. I'll show you another way to create solids. So if you go File, New, and we go to large object millimeters. Okay. Okay. So here on the right are the comments I'll be using. So if you miss one step, hopefully you can catch back based on that. Otherwise, just raise your hand and they'll be able to help you out. So if we start in the top view and we just place a few points on the grid. So either you type points in the command line or you right click on the single point icon. So if you put 4 or 5 points somewhere and press enter, then we can do curve through points. So you need to type that in the command line. So in the command line, when you start typing something, anything that starts with that will appear, and then some more options that have these letters in it will be shown down here. So if we select curve through points and we select our points, so we can select just by creating a rectangle like that. In Rhino, when you select from left to right, it will select anything that's fully in the box. And if you go from right to, I'll show you. Actually, if I create my line, press enter. So now I created my line through points. So if I go from left to right, I'll select only things that are fully in to the box. Whereas if you go right to left, it will select anything that's at least in part in the box. So now it's captured my line. I don't know, when you do more complicated stuff, that can be useful. Actually, if you select just your points, so if you hold the shift key, you can select multiple objects. And we go to layers. And for example, you can put them in layer 1. So if you right click on layer 1, and you can do change object layer. So now they become red. You've changed them. We can hide them because we're not going to need these points anymore. So just click on the ball. So we've created a curve, and now we're going to mirror this curve along the start and the end points as we did earlier. So if we do mirror, select objects to mirror, press enter, start of mirror plane. So again, I have my O snap with endpoint selected, so it's quite useful. I know to go from here to here. So I've mirrored my line, and we'll move this line. Is everybody okay? We'll move this line. So to move it, you can type move, or you can just use the gumball as I showed you earlier. So you can move, point to move from, point to move to, I don't know, just space them a little bit. You can do your own line. Yeah, so that's what we have. Next, we'll create an arc. So these one are all of the arcs you can create. You have different ways of doing it. Otherwise, in the command line, you can just type arc. So here, as I said earlier, you have options on how to do things. So if we select start point, you have the S that is underlined. So either you can click on it, or if you type S, then it will do it for you. So start of the arc will close one side of our two curves. So start of the arc from here. Then end of the arc will be our other endpoint. And then you can choose to create your arc however way you want. And finally, we'll close our last edge with a line. So just a normal line. Again, you type. Just find the way you prefer doing things. And if you go from endpoint to endpoint, we have some form of shape. Now we'll create surfaces. So you have many ways to create surfaces, as I'll show you now. So one of them is to extrude curves, as we've done before. So if I type extrude curve, so if we select this curve to extrude, actually we'll go into perspective, and we'll go into vertical and extrude it by whatever length you want. So that's one way to create a surface. Another one is sweeping along a rail. So if you go into surface, here you have options. So one of them is sweep one rail. Again, you can just type it in the command line. And this will just bring a cross-section along a rail. So I'll select this edge as my rail. And then it tells you to select a cross-section. So this will be my cross-section. And we get a new surface. Just accept whatever defaults. We'll go into shaded. So we've created two surfaces. Another way to create surfaces is loft. So that's between two curves. So if we type copy and we select our object to copy, if we toggle on vertical, then you're sure you're going into the vertical. And if we go from the endpoint to the next endpoint, actually, then you have your two curves. So I said, yeah, the new command is loft, so you can type loft, or you can, again, in surfaces, somewhere there you'll have loft. Yeah, select curves to loft, so we want that one and this one, press enter, and you have your new surface. So again, you have options, but we'll be happy with those. Another way to create surface is this option. So surface from 3 or 4 corners. So you can go from all of the endpoints. So if you zoom, I don't like some. So you can go from this endpoint to that one, to this one, to that one. You've created one more surface. So now we have the outside. We'll aim to create a box, so we need to close it at the bottom and at the top. So at the bottom we have all of our lines, and we need to create a surface from it. So if you go on that drop down menu, again you have surface from planar curves, which is, yeah, so in the command window you type, command line you type planar surface, and you select the planar curves to build from. So we'll have this one, we'll have this one, your bottom one, and this one. And then press enter, we're done. So we have a surface. You could do the exact same at the top, but before we do that, we'll move that edge. So you can either type move edge in the command line. Otherwise, if you do again, as I showed you earlier, the sub-select by doing Control and Shift, and you select that up edge, then you can just move it down. Oh, wait, don't do that. You can always do Control Z to undo. We're gonna join, if you select all of your surfaces and you join them, so using this icon or just typing join, then they're all joined together. So now if we do Control Shift and select the top edge and we move it, then everything is going to move down with it. This is just a line we drew earlier to create our surface. So now we can't do surface from planar curves. but instead we'll do edge surface. So we'll select our open curve. So we have this, 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 and that. And now it's closed it, but it's not flat anymore, obviously, since our lines are not all in the same plane. So yeah, you've created your box. We can close it if you select everything. Actually, we can delete that line now. We don't need it anymore. If you just press delete, it deletes things. If you select everything again, join it. And if you look into properties and you select this, you have a closed polysurface, which is basically a solid. Yeah, so you've got your box. There are many things we could do to it. I'll show you a few things. So first of all, if I'd like to, so here we have the C-plane, which is in this case the top plane. If I want to add something to this surface, there are many ways to do it, but we could change our C-plane to this surface. So if you type C-plane and type surface, then I will oriented my C-plane on the surface. So I want this surface. Origin, doesn't matter, whatever way. So now I've changed my C-plane to the surface. And I can easily draw on it now, and since I have grid snap on. So for example, I don't know, whatever volume you fancy, let's create a pyramid. So I'll go from here. And so now I've created a pyramid on that surface exactly. If you want to go back to the world C-plane, if you go back to C-plane, world, so that's the global one, the one you had to start with every time. So we had the top C-plane, so if we go back to world top, then we're back to where we had it first. Something else you can do is Boolean, so you can remove or add to your volume. So if we create a sphere, so if you type sphere in the command line, and we'll try and make it somewhere near our volume. What's gone? Sorry. Sphere. If you press escape, if something goes wrong, then it will be good. Yeah. So if I create my sphere somewhere here, so you can see it's part of the volume now, but there are two different instances. If you wanted to merge them, you have ways of doing it, so you have different Boolean options. For example, if we do Boolean difference, then we'll select the polysurfaces to select from, so our big volume. And if you select the surface to subtract with, our sphere, press enter, then you can see you've created a hole. But with Boolean, you still have one closed volume. So if I select this thing, it's still a closed polysurface. It's removed from my volume another one. You can also do trim. So if we draw a line anywhere, like here, if I want to do trim, so if I want to remove whatever is to the left of that line, I can use this button here. So select cutting objects, that's going to be my line. And then object to trim will be here. You have to be careful which side of the object you click on, that's what is going to be removed. So I've removed that much, but now, unlike Boolean, it's just cutting through, it's not replacing it with anything. So we don't have a closed polysurface anymore, now we have an open one. So you'd have many ways to close that, but an easy one is cap. So cap. Now it's capped that side, and I'm back to having a closed polysurface. Yeah, everybody okay? Okay. Earlier I mentioned meshes, so we've seen points, we've seen curves, we've seen surfaces. The last thing we haven't seen yet are meshes. That's where, sorry? Okay, sorry. Okay. Okay, then I'll pause for 5 minutes so we can go around and help you catch up, and then we'll get back to it. So if we start a new file, doesn't matter, we can do small objects, millimeters. Yeah, so just a bit of theory. The surfaces and the curves we've been drawing, in Rhino they're called nubs, so non-uniform rational basis spline. So basically, if we go in perspective, I guess you don't have to do that, I'm just showing you. If I draw a line, a curve, and I type control points on, actually, you can see this line is controlled by these control points who are not actually on the line. So curves and surfaces are defined by these control points and the degree of how close you are to these control points. So yeah, if I move my control point, then the curve is going to move with it. And actually when I did my line, here I see degree 3. So if I change the degree to 1, for example, then I'm going to be very close to my control. I'm going to go to the control points and I'm creating kinks. If I go back to degree 3, then I'm back to being quite far from my points. So that's kind of the rationale behind Rhino. So curves and surfaces are actually nubs. We can create a surface. Let me delete those. If we create a surface, this one, between 4 corners, so whatever shape you want to make it. If we go into shaded, and if I go for this one, points on, to get your points on, you can just press F. So if you press F10 or type points on or click on that little icon there, you get your control points. And you can see right now we have only 4 control points. So if I select one of them, and if you have your gumball on, and if I move it up, my surface is going to move with it, but I don't have many control points. So here is going to stay a straight line. If we wanted something a bit softer, we need to add control points. So if we type rebuild, and we select our surface, and we press enter. So originally, the curves are determined by 2 directions, your U and V direction, and in brackets is what we had to start with. So we had 2 control points in the U and 2 control points in V. So here now I have 10 in each, and you can see more lines are appearing and more points will appear. I don't know how many we want. We can pick whatever number just to see what happens, and preview. So yeah, so now I have a lot more control points than I used to. If I select a bunch of them and I move those now, you can see my curve doesn't go straight anymore. My surface, sorry. It's a lot softer, so you can, I don't know, move whatever way you want. Yeah, that's how you control your surfaces. But this is still a surface defined by all of these control points. The other thing, I guess, is meshes. So I can mesh. If we press F11, the point should be coming off. So if I want to create a mesh based on this surface, you select mesh, or you can select surfaces to mesh, and you press enter. Here you can vary the number of polygons you have on your mesh. I'll stick with the default one. That's what I get. Let's move our mesh out of the way. So they look quite different, and I think you're probably more used to seeing meshes, like from FE and stuff. That's what you're used to seeing. So if I select this, the type becomes a mesh. This one, the type is a surface. What you can do on a surface, you can't do on a I mean, you can do it, but not with the same options. So for example, I want to create a little window on my surface. So if I draw a circle here, so it's here, and I use trim, as we've done before. So I select the cutting object, the circle, and then I select the object to trim the surface. So you have to be careful where you trim. Then I'm creating a window. If now I move, so to copy something, you can just type copy and move it. Otherwise, you can, if you have the gimbal on, you can start moving it, and you see up here, it's in the command line, it says tap Alt to make a duplicate. So it will keep my original circle and create a new one. And you have this little plus sign that appears next to the cursor, so that's saying it's creating a duplicate. If we move it somewhere underneath the mesh, so we have our new circle, our other circle. If now I try doing trim onto the mesh, so I select my object, my cutting object, select object to trim, nothing happens. This trim works for surfaces, it works for curves, it doesn't work for mesh. Mesh has like its own world, so if you type mesh in the command line, all of these are the mesh options, and one of them is mesh trim. So now I'll be able to do it. So select cutting object, and then object to trim. Now it's worked. And actually you can see that by doing a 2 trim, something quite different happened. Here nothing changed, it just created the hole. Whereas here the mesh actually changed. So that's because in a mesh, all of the data is stored at the nodes, and you have your edges. So if I remove that part, it disappears, the mesh forgets about it, it's not being recorded. Whereas, so that's done, I've removed that much. Here, I could do untrim, so by right clicking here or type untrim. If I untrim this edge, then it will create it. You can't do that in your mesh. Mesh are a lot more efficient or lighter than surfaces. They store a lot less information. So here, actually, if you select that and press F10, your control points, you'll just have points everywhere on your mesh, but you don't have any data about what used to be there, and it's not here anymore. So I think during the course you will be using meshes a bit more. F11 is to remove control points. Now if I trim this the other way than I did before, so if I just keep the circle, so if I do trim, cutting object, our circle, and we remove, so if I click on the outside of the circle, now I will delete the whole surface. Now we end up with that tiny surface, and you might think that's your surface, you're done, you've removed everything else. But actually, if you do F10 or points on or whatever, you can see it remembers everything, and that's what makes surfaces very heavy. It has the memory of all of your control points. So here it's easy, right? We have one surface. When you have a stadium, not good to keep all of those control points. You can do shrink, trim surface. So if I select this and I shrink it, then I have a lot less control points, but I still have a lot more than just my surface. Whereas here, as you saw, like the control points are every node. And on the surface, when I wanted to delete from it, I had to do trim, create the trimming, cutting edge. On a mesh, you can just delete faces. So if you type delete mesh faces and you select the mesh you want to delete, then you get a hole. To rebuild this, as I said, meshes are much lighter, they don't remember what's been removed, so to rebuild it will be more of a pain than just to rebuild that surface. But you can, yeah, your faces are kind of more independent than here. So if we draw again the surface, you have those lines which are called isocurve, but they don't really mean much. They're just here to show that it's a surface. They're not a physical thing. You can't select the isocurve. You can extract them, but they're not as meaningful as the edges are in a mesh. Yeah, so that was a side note on meshes. We can delete that, I guess. Doesn't matter. So now, if we go back to playing with curves, if we create again a curve, press enter, doesn't matter which curve. So, and we copy it, copy vertical, just to make sure we're in the vertical from the endpoint. I want to create a surface, so I don't know if you remember how to create a surface between two curves is loft. Before I do that, let's just move a bit those control points. So again, if we press F10, just to create some funky surface, doesn't really matter. Okay, so we've got two surfaces. F11 to remove the control points, and we type loft, actually. Okay, these are the things I'm reading, sorry about that. So if we press loft, select curves to loft. Okay, so we get a surface. You might get something weird. If you press enter or the spacebar, it just repeats the last command you've done. So yeah, you might get that. If you do align curves and you select your endpoints, then it should go back to something more normal. Okay, so now we have a curve, the surface, sorry, and this surface was made from our two curves, right? But if I go back to my original curve and I move it, Rhino does not remember. It won't make the surface follow the curve. So if you've done 20 steps, your first step was creating a line, and everything from then was based on that line, and then you realize, oh, I want my first line to be different, and you try to change it, it's not gonna work. You have this thing called record history here, which we can kind of use. So if I delete my first surface, so just press delete to delete. If I select record history, sorry, for you it should be written record history, and I loft now between my two curves. Okay, again, there we go. Okay. And I move now, having toggled on record history earlier, and I move my line, Rhino will remember that the surface is made from these two lines, but this is extremely limited. So let's do again the window as we did earlier. So one way to do it, if you cascade on curve here, one of the options here is interpolate on surface. So I'm going to draw a curve directly on my surface. So if we create our window, press enter. So now it's on the surface. And I do trim now, just to create the window. Trim, select curving object. Enter, object to trim. So I've created my window. I'm done, press enter. I get this message. We've broken the history. So now, if I move my line, we've broken the history, so Rhino just can't remember that our surface was made from this line. And you might want to be able to do that when you do complex projects, and that's when Grasshopper comes into play. So if you open Grasshopper, I guess you don't need to for now, but if you type Grasshopper, you open it. Grasshopper is basically the explicit history of Rhino. So when you do steps, they will show. So quick intro to Grasshopper. You'll have a lot more in depth next week. But that's the canvas. Okay, I'll make it big for now. that's the canvas. You have components up here in different tabs. After display, the basic one when you download Rhino Grasshopper, you have up to display. And then the plugins I showed you in Food for Rhino, if you download some for Grasshopper, they will just appear up there. So what we did in here was create two curves and then loft between them. So this symbol here is for a curve, if I put it on. Okay, people use this little drawings when they, okay, a lot of people use them, but you can choose, I guess, when you start with, to display, to not draw icons, but draw the name, and actually even draw full name. That, when you start with, it's probably easier to understand this than, I don't know, understand something like that. Like, you might not know. When you go on the forums and people post pictures of their scripts, a lot of people use this, but when you start with make your life easy, Paul will probably say differently next week, but you can start with that. So right now it's orange, it's not happy. It needs something, it needs an input. So if I right click here and I set one curve and I set my curve from Rhino, now it's gray. Gray is happy, orange is, it's missing something, and then if it goes red, then it's not happy at all. You're doing something wrong. But usually it tells you what's wrong with it, so that's the good thing. And then if I create another curve, so again, set one curve from the bottom one. So now I have my two curves, and what did we do? Then we did loft, right? So you can either, to find components, you can either go up here in the tabs. So in the surface tab, in freeform, I think one of them will be loft, so this one. Otherwise, to be quicker, or if you don't really know, if you double click, then you get to enter a search keyword, and if I type loft, then it will appear. So sometimes if you can try playing with words and some options will appear, and if you're not sure what you want to do is called, then that can be quite good, or to go more quickly. So if I feed it my two curves, there we go. Now we get, in green is the curve from Grasshopper, the surface from Grasshopper, sorry, my bad. And if now I move my control points, the curve will move with it, because here we have the curves that go into loft, and loft is based on the curves that we've drawn. And if I did trim and everything, okay, it's not the point here, but Grasshopper works from left to right, and if you move something to the left, everything to the right will be impacted by it. So you kind of have your explicit history. If you've done 100 steps and you change something upstream, it will change everything downstream. So that's quite good when you do complicated stuff. Yeah. Just one more. We'll do one quick example in Grasshopper if you want to try and follow. I'll try and be slow. We'll create a cube, because the whole point of Grasshopper is not just to have this explicit history, it's to be parametric. So you'll see a lot more into that over the next few weeks, but if you want to just get familiar with it, we'll just create a cube, something very basic, so we can delete everything that's in Rhino, doesn't matter. We'll just create a cube that we can change the size of. So to start with, we need to create a point. So actually we won't do anything in Rhino, we'll start completely from scratch in Grasshopper. So if you go in vector, and you have point here, actually I can do that. Okay, so here are the comments I'll be using in Grasshopper. So you just use shift and the right click to move in Rhino. So if you go vector, point, construct point, we're constructing a point based on x, y, z, and by default it's taking 0 as the coordinates. You can feed it different coordinates, either by doing a little panel like that. So panel is in params, input, panel. So I can feed it into my coordinates. So I'm doing the exact same as I was. Otherwise, if you do right click, set number, then it will be, you can set one number, but then you can't change that. So right now I'm giving it 0. If I double click here and type 1, then it's going to create a point that is 1 in every direction. This is very basic, doesn't really matter. So we've created a point, then we'll create a next point to define the one side, the depth of our cube. So to do that, we want to move points. So if you just type move, you have your next point. If you feed point in geometry, that's the geometry we want to move. And motion, if you just stay over the word, it tells you what it needs. So it needs a translation vector, and by default it goes 10 in the Z direction. Actually, I want to go in the X direction. So in vector, you have a bunch of options, and if I select unit X, feed it here, by default the length is 1, but I want to change that length, and we'll see one of the core things to Grasshopper, there's sliders. So this is a parameter. So you can just click up here in params input, you have it up here. Otherwise, yeah, we have our number slider. If I double click on it, I can modify it. So I can have floating numbers, integers, even, odd. So right now I have 3 digits, I'll just put it to 0. And I'll vary it from 1 up to 20. So that's my slider is now integers moving from 1 to 20. So that's what you get. If I feed that into the factor, you can see your point moves in the X direction along the vector by whatever length the slider tells it to. So we've got our 2 points. We can create a line between them. So if you just double click and type line, or go into curve, and then this is the line you're after. This is just a line between 2 points. So that little icon. Start point, end point. Now we've got a line. So you can see it in green here. You've got your line. Things that are being created in Grasshopper don't exist in Rhino. So if I try to select it, nothing's gonna happen. I can't select that point, it's just in Grasshopper. It's represented in Rhino, but it doesn't exist. In order for it to exist, for example, if I want this point in Rhino, you can right click on it. If you do bake, baking basically bakes your geometry into Rhino. So I'll create into my default layer. Now I have a point here that I can move, but that point only exists in Rhino. Once you've baked, Grasshopper doesn't impact it anymore. So I can move it, but then it's not connected to my line. This point is not connected to my line. Yeah, just baking. Yeah, so we've got a line. Then we'll create a surface from that line to create the bottom of our cube. So same as in Grasshopper, we can extrude. So if we go into surface, freeform, extrude, or if you just double click and type extrude, we want to extrude our line. And now I want to go in the Y direction. So earlier I used the unit X vector. So now if I double click and type unit Y, or again go in vector, vector, unit Y, I'll feed it the same slider as I want to create a square. And I'll put it in direction, and I'm getting my surface. And my surface is parametric to my slider. So that's the surface. And then to create a cube, we need to extrude once more in the Z direction. So double click, type extrude, otherwise surface extrude, freeform extrude. Our base will be the surface we've created, so it's the extrusion here. And now direction, we create one last vector, which will be unit Z. So double click unit Z, or go vector, vector, unit Z. If I give my vector in direction, right now it has a default length of 1. If I give it this slider, I've created my cube that can have the size varying from 1 to 20. So that's very basic. You'll do a lot more powerful things with Grasshopper in the next few weeks, but I just wanted to give you a quick intro so you know what it looks like next week when we start more in depth with it. Yeah, I think I've covered everything I wanted. So I think we can stay for a bit if you have questions. Yeah.